Hello everyone. Welcome to our presentation on variables and operators in Python. Today, we'll be exploring some fundamental concepts in Python programming. This is the first slide, so I just want to briefly introduce what we'll cover. We'll look into the basics of Python, including variables, operators, and how they work together. I'm excited to guide you through these essential topics. Let's get started. So, what are variables? Well, think of a variable as a container that holds data values. It's like a storage box where you can keep information that your program might need later. In Python, variables are created the moment you assign a value to them. For example, if you write equals 10, you're creating a variable named and storing the number 10 in it. Or if you write name equals Alice, you're storing the string Alice in a variable called name. The key thing to remember is that in Python, you don't have to declare variables explicitly like in some other languages. You just assign a value, and the variable is created automatically. This makes programming simpler and more flexible, especially when you're just starting out. Understanding variables is fundamental because they are the building blocks for storing and manipulating data throughout your code. All right, let's talk about the rules for Python variables. First off, a variable name must start with a letter or an underscore. This is important because if you try to start with a number, Python won't recognize it as a valid variable name. Remember, variables can contain letters, numbers, and underscores, so you have some flexibility in nomming them. Another key point is that Python is case-sensitive. That means if you have a variable called age and another called age, Python treats them as completely different variables. This can be a little tricky at first, so it's good to keep consistent with your nomming conventions. Understanding these rules is essential because they form the foundation of writing clean, error-free Python code. When you follow these guidelines, your variables will be valid, easy to understand, and less prone to bugs as your programs grow more complex. Let's take a closer look at the different types of variables we encounter in programming. First up, we have integers, which are whole numbers like x equals 10. They're straightforward and used for counting or any situation where decimals aren't needed. Next, we have floats, such as pi being 3.14, which are numbers with decimal points, perfect for measurements or calculations requiring precision. Moving on, strings are sequences of characters, like a name set to Python. Strings are essential for handling text data in our programs. Then, we have booleans, which are simple true or false values, exemplified by a flag set to true. These are incredibly useful for decision-making and control flow. Lastly, we have more complex data structures like lists, tuples, dictionaries, and sets. These help us organize and manage collections of data efficiently. Understanding these variable types is fundamental because they form the building blocks for writing versatile and effective code, aligning with our overall goal of mastering programming concepts. Let's take a closer look at the operators in Python. First up are the arithmetic operators, which include the familiar symbols like plus, minus, multiplication, division, and modulus. These are essential for performing basic calculations in your code. Next, we have assignment operators. The most common is the equal sign, but there are also combined operators like plus equals and equals, which make updating values more concise and readable. Then there are comparison operators such as equals, and these are key for making decisions in your code, like checking if one value is equal to or greater than another. Moving on to logical operators, these are and, or, and not. They help us combine multiple conditions, enabling more complex decision-making processes. Bitwise operators, including and, work at the binary level, manipulating bits directly. They're less common but very powerful in certain applications like low-level programming and algorithms. Membership operators, in and not in, are very handy for checking if a value exists within a sequence like a list or a string. They make your code more expressive and easier to understand. Finally, we have identity operators, is and is not. These help us determine if two variables actually refer to the same object in memory, which can be important in certain contexts like object-oriented programming. All these operators are fundamental tools that help us control the flow and logic of our programs, making Python a versatile and powerful language. All right, let's take a look at this example code. First, we have x assign the value 10 and y assign the value 5. When we run print of x plus y, it performs an addition operation, giving us the sum, which is 15. Next, we have print of x greater than y, which is a comparison. Since 10 is indeed greater than 5, this will return true. Moving on, print of x and y demonstrates a logical operator in Python and checks if both conditions are true, and since both x and y are non-zero, it returns the value of y, which is 5. Finally, print of x is y tests for identity, meaning it checks whether x and y refer to the exact same object in memory. Since they are separate variables with different values, this will return false. These examples highlight some fundamental concepts: arithmetic operations, comparisons, logical operations, and identity checks, each crucial in controlling the flow and logic of our programs.